This question is from GATE 2011, Mechanical Engineering paper, question number 51. 1 unit of product P1 requires 3 kg of resource R1 and 1 kg of resource R2. 1 unit of product P2 requires 2 kg of resource R1 and 2 kg of resource R2. The profits per unit by selling product P1 and P2 are rupees 2000 and 3000 respectively. The manufacturer has 90 kg of resource R1 and 100 kg of resource R2. Question is, the manufacturer can make a maximum profit of rupees dash. Let's find out. We have for product P1, requirement of R1 is of 3 kgs while R2 is of 1 kg. For product P2, requirement of resource R1 is of 2 kg, R2 is also 2 kg. Total resource availability of R1 is of 90 kg while total resource availability of R2 is 100 kg. So if we are to produce X units of P1 and Y units of P2, the constraint on R1 is, for R1 the constraint will be 3 times X is the total resource required for production of P1 product, while 2 times Y is the total R1 resource requirement for production of P2. So 3x plus 2y gives us the total requirement of resource R1. It should be less than or equal to 90 kgs. This is the constraint on R1 because 90 kg is the maximum availability. Similarly, we can write this constraint for R2 also. X plus 2y should be less than or equal to 100. We have our two constraints. In addition to this, R1 and R2 should also not be negative. So R1 should be greater than or equal to 0. R2 should be greater than or equal to 0. These are the 4 constraints which we can use to find out our feasible region in which the profit will be calculated. Let the profit be Z. Now after selling P1 product, each unit profit is 2000. So total profit will be 2000x plus for P2, each unit profit is 3000. So total profit will be 3000y. This is the equation for profit. We have to maximize Z to calculate the maximum profit. Let's plot the constraints and see what the feasible region is. When we put X as 0, we get Y as 45 in this equation. So one point on the Y axis is 45, 0. While on the x-axis, if we put y equal to 0, we get x as 30. So the other point is 30, 0. So this is the first constraint. For plotting the second constraint, again we put y equal to 0. We get x as 100. So the first point is 100, 0. While when we put x equal to 0, we get y as 100 by 2, 50. So here's the point 0, 50. So the second constraint is plotted like this. Third and fourth constraints are already plotted. They are the axis itself. So region for this constraint is this one. All of the region between the two axes and the yellow line. While region for this one is this. The overlapping region obtained is this triangle between the first constraint and the axis. So to calculate the maximum profit, we'll have to calculate it on each of the nodes of this feasible region. This node is 0, 0. The profit anyway will be 0 itself. When we put x as 0, y as 0, we have the profit to be 0. Second, we will take calculating z at point 30, 0. So we have 2000 into 30 gives us 60,000 plus 0. So the profit is 60,000 rupees, 60,000. While the last one at point 0, 45. Z at 0, 45 will be equal to 2000 into 0 gives us 0. So 0 plus 3000 into 45 gives us 1,35,000. So the profit here is rupees 1,35,000. We can clearly see that this gives us the maximum profit, and the maximum profit is rupees 1,35,000. Let's go back and mark the correct option. The correct option is option B. Manufacturer can make a maximum profit of rupees 1,35,000. To learn more about graphical method of maximization or optimization, you can refer to the NPTEL video Graphical Method Maximization from the course Introduction to Operations Research. This course is by Professor G. Srinivasan. He is from IIT Madras. I hope this solution will help you clear your doubt. Thank you.